Hi, my name's Dominic Monaco, and today we're going to be covering the TypeScript audit I did for Gridiron Survivor. There's a lot of places we could start with this. Let's just hit on the things we're going to be covering today. So this audit's going to be going over basically the current state of the TypeScript implementation for Gridiron Survivor. We're then going to kind of get into broadly what can be improved upon to increase type coverage and even get into like a few quick examples along the way. So, as of February 2022, this product is an MVP. It's a hackathon project that is being adopted and integrated into the overall repo. What that means is that the TypeScript coverage here is actually pretty bare bones. It works, but there's a lot to be improved upon. A big thing is that we currently have interfaces. We have defined types for the majority of API calls, most of the components. But getting stuff above that into really good TypeScript is kind of where we're aiming to be. So broadly, what can be improved here? Right, there's a couple of key areas I want to highlight. The first one is updating ESLint. ESLint is the file that kind of dictates all the rules our TypeScript follows, so it's pretty important. Next, we want to actually implement something called enums, which we'll get into in just a bit. And we also want to address some current big gaps in our type coverage. Now with ESLint, I recently hot swapped in a file that aligns much closer to what we want to get to at the end. What I found was errors across 50 different files in our repo. So there's a lot of work to be done here. Now to cover ESLint a little bit more, because it's pretty important, if we look at this code example, a lot of this code is boilerplate. What I want to focus on is rules and overrides. These two objects are going to be where a lot of the relevant ESLint comes from that you're going to be interacting with. If you run the linter, if you see the errors, they're all going to be defined in rules or in overrides. So addressing some of the existing errors, we can see on line 3 here, we have the error missing return type in a function. Right, this is an error that's come up a lot, so I feel like it's a really good case study to look into what some of this TypeScript work is. So on the left here, we're going to see a post request. We can see even we have a bit of type coverage on line 3, in which our props are a param, and we can see it's actually a promise with the type of a string, more or less. But this is failing the linter, right? And that's because while we know what data we're putting into this post request, when we send it out and we get an API response back, we don't know the structure of that return, right? We don't know what data we're getting back. So if you look on the right, what we can do is we can actually make a type. We're going to name it draw response. We're going to do a little TypeScript magic and say on a success, it's just going to be the value of true. And on an error, we're going to have a string, which is just going to be a basic error string. Now, if we go all the way down, we can see in the next highlighted section, we can identify this return type as a promise. This promise is going to be a next response, which is a little bit of Next.js magic, but that response is going to be our type, draw response. Now this may seem like a little thing, but what we're doing is we're rendering a lot of implicit ideas about what this code does explicitly. And that informs you, it informs me coming after you, it informs your IDE, and helping just understand what our code does better. And this is kind of the core of TypeScript, is making everything explicit and readable and good. Now moving on, enums. Enums are a special kind of type. Basically, if you ever worked with env variables, they're super similar. We can basically set global constants for unique IDs that we're going to be hitting a lot. So if we have in our database a record table with a unique ID, we can define that globally and we can just always hit that versus defining the ID in every single function call we do to hit that database table. Now, best for last, I have the high priority issues. Now these are 3 issues in which we're not kind of sidestepping, we're not kind of doing things unoptimally, we're actually just leaving the TypeScript ranch altogether. We're way off left field here. In each of these examples, we basically bypass TypeScript and our linters in some way, shape, or form. In the first most example, you can see on that second line, we're actually disabling the linter, so this code runs. In the second example, we were also disabling the linter. And then in the third example, this is some code I did. Just to bypass the linter once again, I just commented out the props. Each of these issues are really good case studies on what makes bad TypeScript. What we're doing here is we're not lacking coverage. We have errors, we know they're there, and we're just hand waving them away. And this is the type of stuff we not only want to avoid, but we need to immediately patch. Now, just to round this all out, our TypeScript coverage is pretty good. We have a few errors here and there. We need to add a few more things, but we're in a really good place. If you have any questions, feel free to ping me. I'll be on the Discord. Thank you.